This video follows the journey of 4 young, brave statisticians who are seeking to find out the true proportion of Gunn High School students that wear their seatbelts. We'll follow the young statisticians as they rise above all the challenges and adversity in their path and eventually achieve their goal.
It's a nice weather outside, isn't it, Philip?
Yeah, it is.
Whoa, is that JJ?
Is he wearing his seatbelt?
I don't think so. You know, wearing your seatbelt is very important. I think all gun students wear their seatbelts. Don't you think so?
At least a vast majority of them do. At least, hey, I think I saw this poster and they made it in like March 2006. It said 89% of gun students wore their seatbelts.
89?
Not 100 though. Huh.
I think more than that wear their seatbelts. We're gonna find out.
What's up, Philip? How's it going, man?
Yeah, I've been thinking, I wonder how we can determine whether the true proportion of gun students who wear their seatbelts when driving is greater than 89%.
Yeah, I don't know. I don't remember how to do that.
Hey, what's up, guys?
What's up, dude?
How's it going?
Pretty good. Dude, you want to sit down?
Sure.
Alright. Hey, we're trying to find out how to do find out if the true proportion is greater than 89% of gun.
Oh, it's easy. You just do a 1 proportion z-test.
Oh yeah. Okay, so how would we start on that?
Oh, just start with your statements. So, first off, what is your null hypothesis?
Man.
So I wonder what the null hypothesis would be.
Well, you saw that poster, right? 89%. Maybe that should be our null hypothesis.
Okay, so the true proportion of gun students who wear their seatbelts when driving would be 89%.
I agree, but what is our alternative hypothesis?
Hey, Jeremy.
Oh, what's up, man? Hey, our alternative hypothesis is that the true proportion of gun students that wear their seatbelt is greater than 89%.
Now that we have the hypothesis done, we can just run the test, right?
Not so fast, Manny. First, you have to check conditions.
Oh, what conditions do I have to check?
Well, you have to check for normalcy, you have to check that it's a simple random sample, and you also have to check for independence.
For this binomial distribution, we'll have to establish that both NP and N1 minus P are greater than 10, which would require 91 data points with our current probabilities.
Well, 91 data points is way too much for independence, because that would mean that we have more than 910 student drivers at Gunn. But I would say it's really only safe to assume maybe 500 drivers.
That would require us to take under 50 data points for our test.
Well, I think, how about 48? That's a safe number.
Sure.
48 sounds good. But guys, what about SRS?
It's very hard to achieve a true SRS in this context. What we could do is we could just take all the cars entering or exiting Gunn in a 1-hour time period, have a Friday on E period, and assume that's a good approximation of an SRS of Gunn students.
I agree.
So do I. In order to conduct this observational test, we went to the front intersection at Gunn High School and observed student drivers as they passed in and out of the school. We recorded which students were wearing their seatbelts and which were not.
Alright, so we succeeded in getting 48 data points.
So after pulling all of our data together, what did we end up with?
44 yes, 4 no.
Okay, let's run the test, guys.
Alright, pull out your calculator, man.
Oh, we're doing a continuous thing, but we're gonna cut that.
We're cutting it now.
Okay guys, so after calculating it with the alternative hypothesis greater than P is greater than 0.89, we got a z-score of 0.59, a p-score of 0.277, and a p-hat of 0.916.
So there's a 47.7% chance that we could have got a proportion of 44 out of 48 or higher based on chance alone if the true proportion was 89%. That's pretty high. So I think since our p-value of 0.277 is greater than our alpha value of 0.05, we don't have enough evidence to reject our null hypothesis.
Nice.
Hey guys, how's it going?
Hey, so we ran the test and we found out that we could not reject HO because we didn't have statistically significant evidence.
I see. Guys, I'm really glad we did this, but how can we improve this experiment?
Well, we didn't have a true SRS because of the context of our study. So if we had a perfect SRS, it would have made our study better. Also, we did choose a somewhat conservative sample number with 48. If we could have found some way to satisfy both independence and normalcy in a way that synchronized better, then that could have also given us a more accurate test.
Nice.
I don't think that's safe, guys. That kid should not be up there.
Nice.